Hello students. So after finishing three numericals on division by t theorem, now we will be starting the next numerical. Now in this numerical, we are gonna see a different function and let's see how to get the value of that or the Laplace transform of that by using division by t theorem. So let's start. So here we have to find out the Laplace of e to the power minus 2t into sine 2t into hyperbolic cos t whole upon t. Now guys, to get Laplace of this, if you observe the given function carefully, then in the denominator we have t, and it reminds me about the division by t property, because in division by t property we have t or t square or t cube in the denominator and the numerator is our function f of t. So here I'll call this numerator as f of t. Now guys, according to division by t property, we have to find out Laplace of this function and we will call that Laplace as phi of s. So here I'll show you the property. So whenever we have Laplace of f of t upon t, the answer by division by t property is integration s to infinity phi of s, and we get phi of s by finding Laplace of f of t. So guys, for that I'll find out Laplace of this function. So to get Laplace of this function, if you see this function carefully, then it has three terms. So we cannot take Laplace of each term separately because they are multiplying each other. So what we have to do is we have to reduce these three terms in such a way that either we can use some standard property or some property or some formula of Laplace transform over here. So guys, what I'll do is for that I convert this hyperbolic cos t into exponential form. So by Euler's formula, this hyperbolic cos t will give us e to the power t plus e to the power minus t upon 2. Now guys, 1 by 2 is a constant. I'll take it outside. This e to the minus 2t will multiply the bracket. Here we will get e to the power minus t, because minus 2t into, e to the power minus 2t into e to the power t is e to the power minus t, plus this is e to the power minus 2t into e to the power minus t is e to the power minus 3t into sine of 2t. So half as it is, and here we will get e to the power minus t into sine 2t plus e to the power minus 3t into sine 2t. And guys, we can definitely find out Laplace of this by using first shifting theorem. So what is first shifting theorem? So here it is for you. So in first shifting property or first shifting theorem, we say that Laplace of e to the power at into f of t is phi of s minus a, where we get phi of s by finding Laplace of f of t. So it means whenever I want to apply first shifting property, it should match with this pattern, that is e raised to at into f of t. Now here in both the functions we have e to the power at into f of d form. So guys, what you can do is, if you want to be very well with first shifting theorem, then go back to my previous videos, and there I've covered the first shifting theorem as well as the numericals on first shifting theorem. So guys, here I'm going to use the first shifting theorem. So if you'll see here, then here f of t is sine 2t, as well as in the second function the f of t is sine 2t. It means in both the functions f of t is same. So by this property, if we have a in the power, that becomes s minus a. So whatever is the sign of a will be changed over here. So Now here a is -1, so that will become +1. So guys, here I'll say by first shifting theorem, so I'll call it as FST. It is nothing but 1 by 2 into phi of s plus 1. Similarly, this will become phi of s plus 3. And to get these two functions, we have to first find out phi of s. And guys, here I'll say where phi of s is Laplace of f of t, and guys, f of t is sine 2t in both the cases. So Laplace of sine 2t is 2 upon s square plus 4. So guys, we are going to use this phi of s to find out phi of s plus 1 and phi of s plus 3. Now, to get phi of s plus 1, we have to replace this s with s plus 1. So this will become 2 upon s plus 1 the whole square plus 4. So we'll get it is equal to half into 2 upon s plus 1 the whole square plus 4 plus, now to get phi of s plus 3, I'll replace this s with s plus 3 in phi of s. So this will become 2 upon s plus 3 the whole square plus 4. Now we can take 2 common, will be cancelled with this 2, and we will get 1 upon s plus 1 the whole square plus 4 plus 1 upon s plus 3 the whole square plus 4. And guys, since this is Laplace of this f of t, I'll write down here for you. So this is the Laplace of this f of t. We will call this as phi of s. So either you can call this as phi of s, or you can still simplify it and then call it as phi of s. So here I'll say it is equal to phi of s. Now guys, as I got phi of s, now it's time to apply division by t theorem, because here we have this function f of t upon t. So here I'll say using so by division by t theorem, the Laplace of this function is given by integration s to infinity phi of s, and phi of s is this value. So 1 upon s plus 1 the whole square plus 4, that is 2 square, plus 1 upon s plus 3 the whole square plus 2 square into ds. So guys, now let's find out the integration of this function and let's get the final answer. So what is integration of this? So it is 1 upon 2 tan inverse of s plus 1 by 2 plus the integration of this is 1 upon 2 tan inverse of s plus 3 upon 2, and this is from s to infinity. So guys, you have to be very well with integration, because if you don't know the formula, then you cannot get the answer. So then from here I can take 1 upon 2 outside, and in the tan inverse function I'll substitute the upper and lower limit. So I'll take half outside, so it is equal to 1 upon 2 inside the bracket. Now let's start with the upper limit. So upper limit is infinity. Here I'll get tan inverse infinity pi by 2 plus tan inverse infinity pi by 2. So it means by substituting upper limit we will get pi by 2 plus pi by 2 minus, now let's substitute the lower limit. So lower limit is s. So guys, by substituting s equal to s, we will get same term again. So I'll get same terms, that is tan inverse of s plus 1 upon 2 plus tan inverse s plus 3 upon 2. Now actually this is the final answer, or if you want to simplify it further, we can do that. So here I'll use a property, that is tan inverse of x plus cot inverse of x is equal to pi upon 2. So as we know that cot inverse of x is pi upon 2 minus tan inverse of x. So you can see this property here. This negative sign will make this minus tan inverse s plus 1 by 2, and here we have pi by 2. So that is nothing but pi by 2 minus tan inverse of x, where x is this bracket. So guys, it is gonna give me cot inverse of s plus 1 upon 2. Similarly, here I have one more pi by 2, and this negative sign will make this as minus tan inverse s plus 3 by 2. So pi by 2 minus tan inverse will be cot inverse of s plus 3 upon 2. So the final answer is 1 upon 2 cot inverse s plus 1 upon 2 plus cot inverse s plus 3 upon 2. Thank you.